Hello everyone, I hope you are doing well. So in this video we are going to discuss Geeks for Geeks problem of the day, and today's problem is search pattern, and in the brackets they have written KMP algorithm. Right now in the brackets, if they have written this particular thing, that particularly means that they want us to solve this problem with KMP only and no other method. So for this particular video I'm going to give a little disclaimer that in this video we are not going to discuss how KMP actually works. We are only going to have a look at the application of KMP as well as Z function. So KMP and Z function are actually very similar, but they are a little different in terms of what they output, but they are used to calculate the same thing, right? Now for this particular video my focus will be only on the application part and how do you actually utilize this pattern matching algorithms, and not how they actually work. If you want to learn more about it, I highly recommend you to watch some other video on YouTube. So you can watch Abdul Bari's video. So his channel is more like a classroom teaching part, and there you can understand the algorithm, how does it actually work, and then you can come back here later for the application and how do we actually apply it to problems, right? So this particular question is very like a straightforward direct implementation of KMP, and let us see what the problem says. So if this is a string, right, this is the original string that we have been given, and we have also been given a pattern. We have to tell the indices at which this particular pattern is present. So for example, it is present at 1, the next it is present at position 9, so 9 is this one, right? So geek is present at 2 places, and that is what we have to return, right? Now in case there is no indices, we can just return an empty vector and they will take care of this -1. So how do we actually solve this problem? Before discussing about KMP, let me just write down there are actually two methods that we are going to discuss today. The first one is z function, and the second one is KMP itself, right? Out of these two, I believe z function is slightly easy to understand. That is why we are going to discuss this first, and then we are going to discuss KMP. So we are only going to have a look at what these functions return. Both of these are, let's say, some black box. So we are going to treat both of them for now as black box. The reason why I am doing like this is because I have never myself felt the need to understand the working of these functions. Whenever I needed them, I knew what they do, and I have always used them in my problems. So we are going to treat both of them as a black box for now, and let us first study what they actually give us as output, right? So z function, let's first talk about z function. So it is going to give me, let's say I have a string s. In both of them we will be having a string s. So in string s at position I, it is going to give me the length of the longest substring starting from position I, which is also a prefix of the string s, right? So what is this? Let us understand this with the help of this example only. So we have geeks for geeks here and we have geek here, right? So if I write geeks for geeks, so let's say I write for geeks, and just let me put some spaces here so that it is easier to see. Right, so this is our original string geeks for geeks, and let's say I also write geek, right? So in these two strings, if you see, what is the length of the longest substring starting from this particular position, which is also present in this in the prefix of this particular string. So for this particular G, what is going to be the answer? The length of the longest string that is also present in the prefix of this particular string. So it is going to be the whole string itself, right? So in this particular case, 1 2 3 4 5 6 7 8 9 10 11 12 13. So if I did not mistake in counting, so that is going to be 13, right? Because we have 13 characters. There are 13 characters starting from this particular position that are also present in the prefix of this particular string. If I talk about E, it is going to be 0, because if we talk about the prefix of the string, it should start with G, right? And G is not present here. So now let us continue to the next particular string. So next character is again E, it is not present in the prefix, K is not present in the prefix, S is not present, F, O, R, and then we have G, right? So now we have to figure out what is the length of the longest string starting from this particular position that is also present in the prefix of the string, right? So we see G is present, G is matching, E is present, E is matching here, and then E, this is E, this is K, and then S and S. So we see that there are a total of 5 characters that are matching. So for this particular position, it is going to be 5. Then 0, 0, 0, 0, right? So this is how we figure out what will be the value of the z function. So whenever we evaluate the z function, we are going to get this particular vector as an output, right? Now a question might be, how is this vector actually useful to us, right? It is not directly useful to us, but this property or this final vector that we are getting is very helpful if we give it a very special input. So what is going to be that special input? So let me just write my original string, the pattern which I want to search, then I put any character in between, and then I write the original string again, X for X. So you see, there are a couple of things that you need to take care of here, but let me just introduce some spaces before. So we have spaces here, then we have spaces, then we have spaces. Right. Now, what we have done, this is the pattern that we wanted to search. This is the original string S. We have written the pattern itself, then a question mark, and then the string itself. Right. So this is a special format that we need to use. Why is this so special? You will see in a while. So for this question mark, you can include any other character as well, which is not present in the string or which is not to be expected in the string. So for example, in this particular case, we are expecting lowercase English letters, Latin letters. That is why we can put a question mark, because we know that this will not be a part of the string in any of the cases, right? You can put any other character which you expect will not come in the string. Now, this part is not very useful till here, but if you calculate the z function for the remaining part, you see for this particular position, what is going to be the answer? For this particular position, the answer is going to be 4 of the z function, right? Why? You will see that this particular g is matching with this particular g, this e is matching with this e, and this e is matching with this e, and this final k is matching with this particular k, right? So we see that starting from this particular position, there is a string or substring of length 4 which is also present in the prefix of the string, right? Now you see we have modified the original string and pattern a little bit, and now we are getting some useful information, right? Now you will also see that this question mark will always break, right? So the maximum length or the maximum value inside the z vector or the vector returned by the z function will always be 4, right? Why? Because this question mark will never be encountered in this particular string, right? So this question mark just acts like a break. You can put any other character as well which is not present in the string. Talking about this particular e, what should be the answer? Right? So the answer for this particular e will be 0, right? Because there is no string starting from this particular substring which is also present in the prefix of the original string, right? So the prefix starts from g, and if you are looking for any character, we should be looking for at least g, right? So here it is 0, here it is 0, 0, 0, 0, 0, and here it is 4 again, because g, e, e, k is matching, g, e, e, k is matching in the front as well, and then again 0, 0, 0, 0. So till now we have got no value other than 0. So let me just write some values as well. So let's say after it g and e was present, right? So for this particular position, the answer is going to be 2, and for this particular position again 0, right? So again, why is this 2 here? Because this g is matching with the front g and this particular e is matching with this particular e, right? So we see we get 2 here because there is a substring of length 2 which is also present in the prefix of the string, right? So this is how we get the answer from the z function. Now how do we actually get our final answer? What we can do is we can start from this particular position and take all those indexes as our answer which have the value of the vector as 4 in it. So why exactly 4? Because 4 is the size of the pattern. So this basically implies that there is a pattern starting from this particular position, right? This is what the z function returns us. At the end, after we have evaluated the z function, we have to take care of all the positions in which the value is equals to the size of the pattern, right? The overall complexity of this particular method is O of n plus m, where n is the string and m is the pattern size, right? Similarly goes for KMP as well. The complexity is the same, but the output that it gives us is slightly different. So I hope that this part was very clear. Again, I'm telling you that we are taking this particular 4 because 4 is the size of the pattern, and we have realized that there is a string starting from this particular position that is also present in the prefix of the string. And what is present in the prefix of the string? The pattern that we wanted to find, right? So if this is equal to the size of the pattern, that means we have found the pattern itself. So this is how we can take care of all the indexes. So this was all about the z function. So what does KMP does, right? Let us talk about KMP as well now. So KMP. So KMP is also very similar, but it has a slightly different output. So in string s at position I, it is going to give me the length of the longest substring ending at position I, which is also a prefix of the string s. Now you see, it is the exact same thing, but now it has become a little bit complicated. Although it has certain different applications, in this particular problem we could have also used z function, but KMP will shine in its own way in certain problems, right? So now let us evaluate the same string, the exact same string using KMP, right? And let us see what will be the output. So you see, like, the explanation of these things is very long. That is why I didn't discuss the algorithm itself. I wanted to focus on the application part, right? Now this part is, as always, not very useful to us because this is the original string and we only care about the values that are present in the original string, right? So now let's say what values do we get here. For this particular position the answer is 1, right? Because what is the length of the longest substring ending at this particular position and present also in the prefix? So this is d itself, right? Now for this particular position, if you remember, for z function we were getting value 0 because this 0 was not present in the prefix. But here you will realize the situation will be slightly different. Here the answer will be 2. Why? Because we are talking about the length of the longest substring ending at this particular position. So this is the end point. This E is matching with this particular E, and this is the G before it. It is matching with this particular G. So you see, from here, from the left side we are taking prefix only, but from the right side we are taking the suffix, right? For this particular position, similarly, the value is going to be 3, and for k it is going to be 4. Why for k it is 4? Because this k is comparable to this particular k, then this E is matching with this particular E, this E is matching with this E, and this G is matching with this particular G. So we see that for the substring ending at this particular position, we can go up to here, and it is of size 4, which is also present in the prefix of the string, right? So you see the output is a little bit different. The thing that we want to achieve here is exactly the same, but the way we are doing it is different, and you will realize that these values might be helpful in certain cases, right? This is not something that the z function gives us, but the KMP is going to give us, right? Now for s it is going to be 0 because s, as you can see, is not present in the pattern itself. For f it is also 0, for e it is 0, for r it is 0 as well. For g it is going to be 1, then 2, then 3, and then 4, and then for s I believe it is going to be 0 again, right? So you see, we have evaluated the KMP as well, and if I would have explained this part to you earlier, then it could have been a little bit confusing, but now I believe it is much more clear after we have studied the z function first. Z function is a little simpler to understand, but it has its own limitation. As you can see here, we can evaluate the suffix as well, which is not possible in z function. It can only be evaluated for the prefix on both the left and the right halves. For the KMP, we are evaluating the suffix on the right half, but on the left half we are still evaluating the prefix, right? So this is how you can find the z function values. Now again, how are these values helpful to us? Now we can again look at the positions which have the value is equals to 4, or basically equals to the pattern size. Now you have to be very careful while dealing with this situation, because these values you cannot take directly, these indices you cannot take directly. You will have to take the starting index of the pattern, right? So you will always have to subtract something from the position you got this particular 4, right? So in like in the z function, what we did was, we, as soon as we were getting 4, we were taking that particular position only, because we know that our pattern starts from here. But for the KMP algorithm, we know that the pattern ends here. It is not the starting point. That is why we have to consider the starting point as our answer, right? Now again, let me discuss the implementation as well. How are we going to implement this for the solution or for finding the answer? So this will be at index 0, this will be at index 1, then 2, then 3, then 4, 5, string 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17, right? So we are going to start from the position 2 into pattern size, right? So the pattern size here is 4 and the position that we want to start is 8. You can clearly see why it is 8, because this is the first position that our pattern can end at, right? This is the first position that our pattern can end at, because this position, this part is actually very useless, it is of no use. Then our pattern cannot end at this particular position, because the pattern is itself of 4 size, so it can never have this value 1, then 2, then 3 and then 4. So this is the actually the first position where we can expect our answer to be there, right? So that is why we are going to start, let's say, our for loop from this particular value twice of pattern dot size, right? And we are going to go till less than this particular string dot size, and let's say we do I plus plus, right? So if at this particular position, let's say if KMP of I, we are at a particular index, is equals to pattern size, right? That means we have found the size of the pattern itself. Then in this particular case, we are going to push back some value to our answer. So let me just calculate that index. So int index, right? You see here, we have this particular value 8 as our I value or our current index, but we want the value 1 in our answer, right? Because this was the starting position 1 and we have found this pattern starting from here. So how do we actually get it? The very first thing we would want to do is I minus pattern dot size, right? Why we are doing pattern dot size? So actually we'll have to do twice of pattern dot size, not pattern dot size itself. Since we are starting from twice of pattern dot size and then we do I minus twice of pattern dot size, we will get 0 at this particular position, right? When we are at 8, we are going to get 0, right? But we need 1 based indexing, that is why we are going to add 1 to it, and hence this is going to be our final index, and I am just going to push back index to my answer, right? So let me just reiterate this part again. So starting from this particular position, you will realize that I want this index to be 0 or 1, right? 0 in 0 based indexing, 1 in 1 based indexing. Since this is the starting position and I have taken here the starting to be twice of pattern dot size, I do I minus twice of pattern dot size, the same positions that I have started with from the current index I. This is going to give me 0, right? Now to make it 1 based, I can just add 1 to it, right? So this was all about this particular problem. Now let us have a look at the final implementation. So you see, this is the prefix function or the KMP algorithm here. Now you might ask, how do we get it? Now whenever you are you want to solve this kind of problem, what you can do is you can search for KMP algorithm and then type CP algorithm after it, right? So you will get this particular blog. This is a whole website of different algorithms. Now you can move on to the implementation here and then you can just directly copy this particular part. If you want the Z function as well, you can see that Z function is also present here. You could also go to the implementation. So you can see this is the implementation here, right? So similarly, you will be able to get the implementation of both the algorithms very easily, and then you can just copy this particular part to your code. Now once you have copied it here, now you can see I have constructed the final string as the pattern plus a question mark plus the text or the string that I want to search in, right? Now I initialize my KMP as prefix function of that particular string look, and I have initialized my answer. So now what I do, I initialize my start with twice of pattern dot size. I is starting from this particular position start, and I go till I is less than look dot size. If KMP of I is equals to pattern dot size, I am going to push back I minus start plus 1, right? I already explained why we are doing this, and at the end we can just return the answer. Now this was all about for this particular question. Now I leave it as a task for you. change this particular function to z function. You can again get it from the CP-Algorithm's website. Change this particular function to z function and then modify this particular part, right? Now I have already explained how the z function works, and trust me, it is very easier to implement this particular part for the z function as compared to the KMP for this particular question only, right? So as I have already said, KMP shines in its own way. It has different applications. So in this particular problem, you can use either of them. Z function is very simple to implement, so you can try to implement z function as a task, right? Now if I just submit and show you, so you see it passes all the test cases and this solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.